Good morning, everyone. And today in this class, we are going to learn about eukaryotic transcription. And in this video, we are going to learn deeply about the eukaryotic transcription mechanisms. So, what are all the enzymes which will helps to transcribe our mRNA? What happen after transcription? What are the transcription inhibitory factors are available? So these things we will elaborately discuss here. Okay, so this is a pictorial representation of transcription mechanism. First your template DNA is here, and followed by this your RNA will synthesized. These processes happens inside your nucleus, cellular nucleus. After transcription, your mRNA moves on to the cytoplasm and then give codons to synthesize. What is that? Your proteins, your polypeptides. So these process, your translation will happen outside the nucleus, that is your cytoplasm. Okay. Eukaryotic RNA polymerases. So here, what are the enzymes which will helps for the RNA polymerase, RNA synthesis? Okay. In prokaryotic, what we saw, RNA polymerase only with RNA polymerase having 5 subunits. Okay. Here, in contrast, in eukaryotes, RNA polymerase 1, RNA polymerase 2, RNA polymerase 3. See, and RNA polymerase 1, the role is transcribes or synthesize. Okay, RNA polymerase 2 transcribes. RNA polymerase 3 also transcribes. Okay, and these are the subunits, which has 28S rRNA, ribosomal RNA, and 18S, 5.8S. Oh, so why these kind of subunits here means, according to the organism, it may vary. Okay, RNA polymerase 2, mRNA, some snRNA. These are the type of RNA polymerase 2. RNA polymerase 3, tRNA, 5S RNA, some snRNA. These are all coming in the RNA polymerase 3. So, this is the RNA polymerase 2. RNA polymerase 2 is central to eukaryotic gene expression and has been studied extensively. So for eukaryotic gene expression, this is the central polymerase. Okay, RNA polymerase 2 is a multi-subunit enzyme with 12 subunits. See, it has 12 subunits. RNA polymerase 2 requires an array of other proteins called transcription factors. So, the RNA polymerase requires an array of other proteins that is called transcription factors. So, the transcription factor also has several types are there. So, here the transcription factor 2. So, here what is the transcription factor? Especially transcription factor 2, in order to form an active transcription complex. So as I told you already, which is a quite difficult mechanism to understand. So kindly cooperate. Eukaryotic RNA polymerases. RNA polymerase 1, 14 subunit. RNA polymerase 2, 12 subunits. And RNA polymerase 3, 15 subunits. Okay. So these are the subunits. So this is the inhibitor of eukaryotic RNA polymerase, mainly type 2 RNA polymerase inhibitor, which is nothing but alpha amanitin. It's a fungal toxin from Amanita phalloides. Okay. So types and location. So no need here. We will go to the transcription process. Eukaryotic transcription. I'll tell you this later. I'll tell you. Now you no need. So after knowing the mechanism only, you clearly know what is transcription factor. So now we directly go for the transcription process. So eukaryotic transcription first, as a in when the process is starting, the first thing is we need to promote, initiate the mechanism. So what has happened here? Promoters much more complex than those found in bacteria. So as I told you already now, which is quite competitive, quite confusing and quite difficult to understand. So these are consensus sequences located at the upstream region of coding region. Mutation of this region usually significantly lowers the rate of transcription. See, so here the promoter region has the consensus sequences located at the upstream region of coding strand, as we all know. If any mutations present in the sequence, there is which lowers the rate of transcription. So it will automatically affects your transcription rate. So see here, this is the GGGCGG minus 110 upstream region. This is a GC box, and here minus 70 CAAT cat box, and minus 30 only you have Tata box. After that only your transcription start site is present. So this is your promoter region. Okay, Tata box. And Tata box. What is Tata box means? Which is your promoter sequences here. Very similar to the prokaryotic Tata box. Okay, except the sequence is slightly different. TA. So what is present at prokaryote? Tata at. But here in eukaryote, it is Tata. It's a triple A. It's located between minus 25 to minus 35 upstream, which is also called as a Hogness box. And in case of what is that? Prokaryote is a Trenbow box. Okay, cart box. And next cart box, which is located between minus 17 to 80 upstream region. And the GC box usually has sequence. See the sequence GGGCGG, and is typically found at minus 110, and followed by that enhances element or the sequence located in a variety of regions of gene, both upstream and downstream of transcription start site, and even within the transcribed portions of some genes. Enhances increases the transcription rate by several folds. Okay, so enhances are the main sequence which will enhance the transcription rate. So see, this is the upstream region and this is the downstream region. So downstream region it will calculate it as a plus symbol, and upstream region which is denotes a minus symbol. So first GC box, cat box and Tata box. So this is the proximal control elements and followed by your core promoter. After core promoter, your transcription start site. Okay. Transcription factor. What are all the transcription factor? As I told you already, RNA polymerase 2 does not bind to the promoter sequence directly. But in case of prokaryotic transcription, what is that? Your promoter region. What will bind to you? Recognize your promoter region? Yes, of course. Your sigma factor, which will bind to your core enzyme, that will automatically recognize your promoter region, which will present in your prokaryote. But here that will not happen. So what will happen means RNA polymerase 2 associate with 6 transcription factor. So here RNA polymerase directly does not go and bind to your promoter sequence. Instead of, it will go and bind with your 6 transcription factors, and then only it will go and recognize your promoter factor, and that bind and unbinding happens automatically. Okay. So what is that 6 transcription factors means? Transcription factor 2A, transcription factor 2B, D, E, F and H. So these are the transcription factors, 6 transcription factor which will go and bind to your RNA polymerase 2, and then only your promoter region will recognize and your transcription will start. Proteins required for initiation of transcription at the RNA polymerase. So what are the proteins which will need for initiating transcription means polymerase 2, which has 12 subunits, and then TBB, Tata box binding protein, which will specifically recognize the Tata box. In case of prokaryotes, which subunit will go and bind to your promoter region, recognize your promoter region? That is your alpha subunit, which will present in your RNA polymerase. Okay, but here Tata box binding protein, which will specifically recognize the Tata box. Okay, TF2A, B, E, F, H. These are the your 6 transcription factors, and this is the specific role of each transcription factors. Okay, so here pre-initiation complex will form. So before the transcription starting, the pre-initiation complex will form. So what will happen in this case? Tata box binding protein of TF2D binds Tata box at upstream 10 sequence, and TF2A and TF2B bind TF2D. That is your transcription factor D. And TF2F RNA polymerase complex binds TF2B. Yes, I know this is quite complicated, so kindly listen, then only you learn. Okay, there is no other way. You should go through these names A, B, F, what is here. You automatically you will learn it. There is no other options. Okay. So what is here? TF to F and E open the double stranded DNA helix. Once the binding process is done, the F and E open up the double stranded DNA with the help of helicase and ATPase enzyme. So after what will happen? TF to H completion of what is the TF2H does means is do the completion of PIC. PIC which is just nothing but your pre-initiation complex. After binding TF to H, the pre-initiation complex will form. See what are all the things which is present in pre-initiation complex? Your RNA polymerase 2, Tata box binding protein, and with all the transcription factor subunits. So this is the pre-initiation complex, and this is the mechanism of what are all the transcription factor which is come first, which is come next. Based on that only they will explain. Okay, pre-initiation complex. See the pre-initiation complex. What is present in pre-initiation complex? Your DNA, your double-stranded DNA, RNA polymerase 2. The blue color is light blue is your RNA polymerase 2, and TBB, your Tata box binding protein. That is here. This dark blue is the Tata box binding protein plus transcription factors. Transcription factors has the 6 subunits TF2D, F, B, H, E, and A. These are the transcription factors. So altogether we call it as a pre-initiation complex. Okay. Now our pre-initiation complex will form. After what will happen? Phosphorylation of RNA polymerase 2. TF2H is a protein kinase activity to phosphorylate CTD of RNA polymerase. CTD is the C-terminal domain of RNA polymerase 2. So C-terminal domain of RNA polymerase 2 will get phosphorylation with the help of transcription factor 2H. Okay. After only the RNA polymerase can move towards the downstream. Where the downstream is present? When the transcription starting site is there, that is your downstream, which will denote like a plus symbol. Okay, starting the elongation phase. Most of the transcription factors fall off from PIC during elongation phase. As I mentioned you already, what will happen in DNA polymerase as when it is act as a whole enzyme. Once the initiation starts, the sigma factor will goes off from it, and then it will call it as a core enzyme that will move on to the elongation process. The same kind, the pre-initiation complex carry the 6 subunit of transcription factors. So, uh, when the elongation process will start, the all 6 subunits of transcription factors will automatically fall off and the elongation process will start. Okay, see, this is the CTD end of your DNA polymerase, RNA polymerase 2. At that end only your transcription factor will polymerize the phosphorylate the RNA polymerase 2. After that what will happen? See, the double strand will unwind, it will open up, and then what will happen? Here this is your altogether, this is your transcription factor. Initiation takes place and elongation will move on. Automatically the transcription factor will moves from your RNA polymerase. After moving, the elongation will automatically start. Now we coming to the termination. See here, the quite complicated portion is your initiation. Initiation, pre-initiation complex, and recognition factors, transcription factors. These are the quite complicated things. After that only it will move on like smooth. Okay. Termination. When the RNA polymerase transcripts the terminator region of a DNA, the polymerase releases the mRNA. See, when the RNA polymerase transcripts the terminator, here RNA polymerase are only transcribe the terminator region. See, RNA polymerase can also synthesize the RNA, and moreover it can transcribe the terminator region also. Once it will transcribe, the polymerase release the mRNA. So the polymerase, what will happen? The polymerase it's like a hand-like structure. It will hold the your newly synthesized mRNA. Once the region is terminator region is transcribed, the polymerase, what will happen? The polymerase will automatically release your mRNA. Okay. The termination sequence is AATAAA followed by GT repeats. So instead of that, what we saw in prokaryotes, some GC sequence followed by U repeats. Okay, UAA. Okay, but here in contrast, AATAA followed by GT repeats. Okay, elongation. TF2F remains associated with RNA polymerase throughout elongation. The activity of RNA polymerase 2 is greatly enhanced by proteins called elongation factors. So again here, in initiation what will happen? Transcription factor, along with the transcription factor, RNA polymerase 2 will synthesize the RNA, and for elongation also it will go and bind with the help of elongation factors, then only your elongation takes place. And this is the template DNA. So this is the process of your termination. As I told you already, is the RNA polymerase is a hand-like structure. Once the region is AAUAA, is the terminator region, it will give signal. The palm-like structure of RNA polymerase will release the newly synthesized. This is your nascent RNA. Will release the RNA. Cleavage by specific endonuclease. Endonuclease means within the nucleus some cleavage will happen. Addition of tail by poly A. So after poly A, adding adenine into the tail. See, this is the poly A. This is now number of A adenines. So tail. The 3' hydroxyl. This is called polyadenylation. Polyadenylation. This n numbers. This is numerous adenine will added in this process. So that only it will call it as a polyadenylated mRNA precursor. Precursor means this is not a whole mRNA. Before synthesizing the whole mRNA, this is called a precursor. So after termination, so from this your termination will over. So now we'll go on for your inhibitors of eukaryotic transcription. Mitomycin and adriamycin and cyclosporin, DRB, flavopiridol. What is this? Tagitoxin. These are the transcription inhibitor is used in current market. Okay. And the next one is their post-transcriptional modifications. We'll discuss in next class. Okay. And thank you girls. Thank you for your kind cooperation. If you have any doubts, you'll send me and call me. Okay. I'll rectify your doubts. So okay. Thank you once again. Thank you girls. Thank you, ma'am.